use a heating curve, and if you have a heating curve in front of you, it's the staircase one that's really going to help you. So hopefully you can pull that up from yesterday. Today what we're going to do is just show you how you can do multi-steps with that. So yesterday we only did one step at a time. Now I'm going to show you how you can do more than one. So if you look at this question, it says how much heat is absorbed. So first of all, I see the word absorbed, and I know that energy is going in, which means I'm going to get positive values for my energy. You have 55 grams of ice at negative 15 degrees Celsius, so that's going to be the very bottom diagonal line, and it's converted into liquid water. So when you get to that first flat line on your staircase graph, at the left of that is all solid, and on the right of it is all liquid. So as you cross from the left to the right across that horizontal line, it turns from a solid to a liquid. So what we have to do is two different steps here. First, we need to heat the ice until it reaches 0 degrees, because that's where we can melt it. And then once it's at 0 degrees, we actually have to go through the melting process. So we have two different steps here, and we're going to do two calculations. The first one is just taking the really, really cold ice and making it a little warmer. We're not going to melt it, we're just going to change the temperature of it. So anytime you're just changing the amount of temperature for one state of matter, you can use the MCAT equation. So if you plug in your mass is 55 grams. Since it's below 0, I know that it's solid ice, so 2.05 is the specific heat of ice. And then for your temperature change, don't forget to do final minus initial. So for this one segment, we're going to end at 0 degrees. We're starting at negative 15. So you should do 0 minus negative 15. And that should give you a positive value for your final answer, which makes sense because heat is being absorbed. This is just the amount of energy that it takes to get the ice to go from negative 15 degrees Celsius up to 0. Now that it's at 0, now we can go through the process of melting it. So we have to add some more energy to melt it into a liquid. And anytime you do a phase change, the equation that you use is Q equals M times H. If it's solid to liquid, you use fusion. If it's liquid to gas, you use vaporization. So in this case, we're going to use the heat of fusion, and you can look that up in your reference packet. It's 334 joules per gram. Multiply those, and you should get another positive number. Then you just add the two together. So once you get all your different energy amounts, put them together, and you can get your total heat for this process. Let's try a couple more that take more than one step. And again, if you have that graph, it'll definitely help you. So for the next question, it says how much heat is absorbed if 45 grams of water at 20 degrees goes to steam at 110 degrees. So if you look at your graph, 20 is on that middle diagonal line. So the diagonal goes from 0 to 100. So we're starting at 20. We're going to go all the way to steam, which is on the top diagonal line at 110. So we have three different steps here. First, we have to heat the water from 20 up to 100. Once it's at 100, we can actually boil it. And then once we've boiled it, we have to heat that gas up to 110. So every time you turn a corner on that graph, you have to do a new calculation. For steps 1 and 3, we're just heating one state of matter, so we can use the Q equals MCAT equation. For step 2, it's a phase change, so that's going to be Q equals M times H. So here's our first step. We have 45 grams. It's liquid water, so we're going to use 4.18. And this is the part where most people mess up. So if you're zoning out right now, this is the time to listen in. A lot of people are going to take this final temperature 110 and subtract 1 from 20, so they do 110 minus 20. But if you look at your graph, for this first segment, we're just going up to 100 degrees because we can't boil it until we're at 100. So we're going to stop at 100 degrees Celsius because that's the boiling point. So don't necessarily use the two temperatures together. This is just the amount of heat that it takes to get the water up to 100 degrees. Now that it's at 100, now we can convert it to steam using Q equals M times H. And since we're going liquid to gas, we want to use vaporization, not fusion. So when you look at the reference packet, choose the vaporization one. Then for that last step, we're just heating the steam, so we can get back to the MC delta T equation. You have a different specific heat now because it's a gas, so be careful that you choose the right specific heat. And be really careful with your temperatures. For this last segment, we're starting at 100 because that's where we boiled it, and we're going up to 110. So your temperature change here is 110, that's your final, minus the initial is 100 because that's initially where you started just for this segment. And then before you add them all up together, make sure that they're all the same kind of sign. So since heat is being absorbed, all three of these need to be positive. And if you need to pause this to write down all these numbers, that's fine. Go ahead and pause the video and you can fill it in. The last question says how much heat is released. So this time we're going to do exothermic, which means that they're all going to be negative. We have 500 grams of vapor and we're starting at 140. We're going all the way down to 60. So we're going to go down the graph this time. So first we have to cool the 140 down to 100. Once it's at 100, we can turn the gas into liquid. That's the phase change. And then once it's a liquid, we can cool it down to 60. So if you just look at your graph, it'll help you figure out what you need to do. We're going to cool the vapor down to 100. Then we're going to condense it into liquid water. And then we're going to cool the liquid down to 60. So for the first segment, we're just cooling the vapor, so we can use the MCAT equation. Make sure you choose the right specific heat because it's a vapor, and be really careful with your temperature change. We're starting at 140, but for that top segment, we're going to stop when we get to 100. That's where we're going to condense it. So our temperature change is 100 minus 140. Notice that we got a negative number because heat is being released. Then we're ready for the condensation step. So we're going to do M times H. And since a vapor is involved, we're going to do heat of vaporization. But be really careful with this one because when you get your answer, it's going to be positive. You have to actually put the negative sign on there. If you don't put that negative sign right there, when you add these up together at the end, you're going to get the wrong answer. So again, before you add them up, all of your numbers should either be all positive or all negative. You shouldn't have some of each. And then the last step is we need to get it from 100 down to 60. So now we have liquid water, so we're going to use 4.18. Final temperature is 60, but for this one segment, we're starting at 100. We're not going all the way back up to the beginning at 140. We're starting at 100 where we condensed it. Notice that it's negative, so that makes sense. And then you just add them all up together. So for each of these, I would say use that graph and try to figure out where you're starting and stopping, and that'll definitely help you. And that's it for today. So if you want to try some of these, worksheets 4 and 5 should be all problems that are multi-step, and they should all have the answers on them so you can check your work as you go. And that's it for today.